Now, adding and subtracting fractions is a little bit more tricky compared to multiplying and dividing. When we were multiplying and dividing, we didn't care whether the denominators were identical or not. When we're adding and subtracting fractions though, it's a completely different story. We have to have common denominators. In other terms, the bottom of the fractions should be identical for us to be able to add the fractions, or subtract them for that matter. So whether it's adding or subtracting the fractions, first look at the denominators. Then once you've identified that the denominators the same, just write it once, and then put the numerators together in one fraction. And finally, copy the sign in the middle. If it's a plus, make sure to put a plus. If it's a minus, make sure to put a minus. And then compute the summation. In this case, 12 over 24. Once you're done, try to reduce the fraction to lowest terms. 12 over 24 is the same thing as 1/2. So this is how we do the process if the denominators are already matching. If the denominators don't match, we'll have to make the denominators match first by looking for the LCD, making equivalent fractions, then combining. We'll do that on another page. So let's take a look at example 16, which says 5 over 24 minus 7 over 24. So notice how the denominators in this case are already equal to one another. So that's great. They are already same. If they're not the same, it will be a little bit more difficult. So because the denominators are the same, we just write down 24 once on the new problem, on the new fraction. And we copy the 5, the 7 together into one fraction, and we put the minus in the middle as well. So here we go, 5 minus 7, which by the way is going to be -2 over 24. And as usual, you want to reduce the fractions whenever possible. So you want to break it down as much as possible. In this case, 2 and 24 can both be divided by 2. And if I divide them by 2, I'm going to end up with 12. And notice if I don't put anything on the numerator, it's confusing. So that's the reason why I'm telling you put a 1 whenever you can. So again, when we're adding, it's pretty much the same process. 7 over 60 added to 8 over 60. So first, make sure that your denominators are equal to one another. So they're both 60, which is great. So they're identical, they're equal, they're the same. So that means we are going to copy that denominator over to the new fraction. Notice we don't add the denominators, we just write it down. And the numerators were 7 and 8. We're going to put them together and a plus sign in the middle because that's what used to be between the two fractions. So we even do the same thing when we're adding polynomials or subtracting polynomials. We just need to put some extra parentheses to be safe. So we'll do that in another page. So in this case, 15 divided by 60. And as usual, you want to try to reduce this to lowest terms. So 15 and 60, I believe, can both be divided by 15. We get 1 and we get 4. And again, notice that if the 1 is missing, you might want to write 4 instead, which would be wrong. It's supposed to be actually 1/4. So 1 is important in this case, so that's why I'm stressing to write down the additional 1s. So we just saw how to add and subtract fractions when the denominators are already equal. What if the denominators are not equal? So, looking at 18, I have 3 over 24, and then I have 7 over 16. So again, in this particular case, the denominators do not match. So they're not the same. So my first job is to make them somehow match. And to do that, I'm going to have to do some sort of LCD business. So let me go off to my scratch paper and break down the 24. 24 is the same thing as 3 times 8, which is the same thing as 3 to the power of 1, 2 to the power of 3. Whereas 16 is the same thing as 4 times 4, or in other terms, it's 2 raised to the power of 4. So the LCD, looking at both of these answers, the first one and the second one, I can see that the base 2 and the base 3 showed up. The base 2 showed up 4 times, that's the most, and then base 3 showed up once, the most. So multiplying these two answers, I can get the solution and find out what the LCD is. So now that we know what the LCD is, we're going to form equivalent fractions. So we're going to write down the original problem, but with the LCD instead of the original denominators. So in this case, 48 and 48. So now think about this for a moment. How do you get the 24 to become 48? What do you multiply 24 by to make it 48? Well, normally you would multiply it by 2. So since we're multiplying the 24 by 2 to make it 48, we're going to do the same thing again with the 3 and multiply that guy by 2 as well. So 3 times 2 will be 6. So this is the equivalent fraction to the first one. We repeat the same process again with the 16. What do you multiply 16 by to make it a 48? Well, you multiply it by 3. So repeat the same on the numerator. 7 times 3 will now be 21. At this point in time, the denominators are matching, so we can write down the 48 and put the numerator 6 minus 21 together in one fraction, which would give us negative 15 over 48. Again, it is always a good idea to check whether things can be simplified, whether things can be divided out or not. So in this case, I can divide the 15 and the 48 by 3, for instance. If I divide them by 3, I get negative 5 over 16. So that's my final answer. Now, this is not the only way to do things. I could have saved myself a lot of time if I had noticed that 3 and 24 can be both divided by 3 to turn it into 1 divided by 8 instead. That may have saved me a little bit of time because it may have made the denominators a little bit smaller, a little bit more manageable. But I just want to show you that no matter how you do the process, at the end, the solution will still be the same. So let's take a look at the next one, 19. It says 13 over 24 and 5 over 9. So think about what would the LCD be in this case? Well, let's see. 24 is 3 times 2 cubed, just like before. 9 is the same as 3 squared. So the LCD would have to be 2 to the power of 3, 3 to the power of 2. So this is literally 8 times 9, which is 72. So my LCD is going to be 72. So I'm going to have two fractions with a 72 instead of 24 and a 9. So now think about, what do you multiply 24 by to make it 72? So 24 to become 72 needs to get multiplied by 3. So we do the same thing with the numerator. 3 times 13 will be 39. And again, think about, how does the 9 become 72? What do you multiply the 9 by? Well, you multiply by 8. So we do the same thing with the numerator. 8 times 5 will be 40. At this point, the LCDs are the same, so the denominators will match. So we get 72 on the denominator, and then 39 rather, minus 40, which is a negative 1 over 72. And that's how the process ends.